Hey, what's up, guys? It's Mr. Gooden from Gooden's Math, and today we're going to be talking about solving system of linear equations by graphing. All right. So whenever we solve a system of equations, we're trying to find an x and y value that works for both equations and makes both equations true. All right. Now, when we're doing graphically, all we're basically doing is just going to graph both equations and then see where they intersect. And when they intersect, that point where they intersect is going to be our solution. So the first thing we want to do is, when we're looking at the system of equations here, we want to make sure that they're both in slope-intercept form. Slope-intercept form, if you remember, is going to be y equals mx plus b. If you remember, m is our slope and b is our y-intercept. Okay, and if you don't remember what slope is going to be our rise over run. Okay, now when we look at both these equations, all we have to do is basically, since they're both in slope-intercept form, we don't have much work to do. All we got to do is find the slope and y-intercept for each one. So if we go over here and we take a look at the first equation, we can see that first equation, or m, would equal right here 2, and I like to write it as a fraction over 1 because that gives us our rise over run. And then our b right here would be -3. Our y-intercept would be -3. And in our other equation over here, we have our y-intercept is, our slope in front of the x. There's no coefficient there, so that means there's a 1 here, which makes our m, or our slope, 1 over 1. And over here, our b in this case would be -1, our y-intercept. Alright, so let's do the first line, which is y equals 2x minus 3. All we're going to do is we're going to plot our y-intercept first, which is -3, and then we're going to apply our slope, which is up 2 over 1, rise 2 over 1. So we're going to go up 2 over 1, up 1, 2 over 1, up 1, 2 over 1, up 1, 2 over 1, and up 1, 2 over 1. And I like to do the whole graph. I like to see a good, good visual of the whole graph. So I'm going to continue backwards. So 1, 2 over 1, 1, 2 over 1, 1, 2 over 1. All right. And then we're going to draw a line. Let me get a nice line here, nice straight line. Do the best I can here. Let's do red, and it should look something like this. All right. The couple things you want to make sure you do is always make sure you have your arrows on the ends of your lines. And also, if you know you're going to graph more than one line on the coordinate plane, or more than one graph on a coordinate plane, you want to make sure you label your line. So this line would be y equals 2x minus 3. All right. Now let's do the blue line here, or the second line. So what we're going to do is we're going to plot our y-intercept, which is -1 first. And we're going to apply our slope. And our slope is going to be up 1 over 1. Up 1 over 1. Up 1 over 1. And as you can see, it already crossed, but I like to show a good visual of our line whenever I'm graphing. And I'm going to continue backwards. Alright, and let me get a nice line for that. Let me straighten out that line a little bit more. There we go. Alright, and that's what our line will look like. And don't forget to label your line. So it's going to be y equals x minus 1. So there's our two lines. Now, as you can see, they intersect, and that point where they intersect, right here, is going to be our answer. And that answer is going to be 2, 1. And remember, write it as an ordered pair. That's going to be our answer. That's our solution. This point right here makes both equations true. Now, sometimes you may mess up and you may plot the wrong y-intercept, or you might mix up your slopes and do a negative slope rather than a positive slope. So what you should always do really quickly is just check your answer. A lot of people skip this step with checking their answer. So let's go ahead and check our answer. Alright, so all we're going to do is plug in x and y into both equations and see if they make both equations true. So we're going to take this x and a y and substitute it right in here. So we're going to wind up with 1 is equal to 2 times 2 minus 3, and you wind up with 4 minus 3, and you can see that 1 is equal to 1. It makes the equation true. And then the second one, if we go ahead and do that one, is going to be 1 is equal to 2 minus 1, and obviously 1 is equal to 1. So you can see that it checks out for both equations. So therefore 2, 1 is going to be our solution to this system of equations. All right, let's try another one. Now, sometimes you're going to have this type of scenario where you're going to have equations where they're not going to be in slope-intercept form. So what we're going to have to do is make sure we put them in slope-intercept form in order to graph them real quickly. So what we're going to do is we're going to have to solve for y, all right? So I'm going to do both equations. Let's start with this one. The first one, I'm going to do it over here. 3x plus 4y equals 12. So what we're going to do is we're going to solve for y. So we're going to minus 3x, and we wind up with 4y is equal to 12 minus 3x. And since these are not like terms, we can't combine them, so we just leave it as 12 minus 3x. And then we are going to divide by 4. So now we're going to divide by 5. We're going to divide by 4. There you go. And when we divide by 4, guys, we're going to divide each one of these terms by 4. So it's almost like distributive property, what with division. So we're going to divide 12 by 4, and we wind up with y is equal to 12 divided by 4, which is 3. And negative 3 divided by 4 is going to be negative 3/4 x. Now, a common question I get is, Mr. Gooden, why do we, we're going to get a fraction? There's nothing wrong with a fraction, guys. And in particular, this fraction works out really well for us because this gives us our slope. And remember, 3 over 4 just represents our rise over run. All right? So in this case, our m is going to be equal to negative 3/4, and our b is going to be equal to 3. Now let's go to the second equation here. 2x plus 4y is equal to 8. So now we're going to solve for y. So we're going to minus 2x. We wind up with 4y is equal to 8 minus 2x. And then we're going to divide by 4 just like before. And we wind up with y is equal to, now again, we're going to distribute this 4, right? Well, not distribute, but we're going to divide each one of these terms by 4. So 8 divided by 4 is going to be 2 minus negative 2 over 4 is going to be negative 1/2 x. All right, and what do we get? Our slope is going to be equal to negative 1/2, and our b, or y-intercept, is going to be 2. Now that we have them both in slope-intercept form, we have our slope and our y-intercept, all we have to do is graph them and see where they intersect. All right, so we're going to go ahead and take a look at this one here first, and we're going to plot our points. So our first point is going to be our y-intercept, which is 3. So we're going to go over 3 and plot our first point. Now, I teach my kids when it's positive, we rise over run, and when it's negative, we fall over run. So we always run right is because when we read a graph, we read it left to right. So negative slopes go down to the right and positive slopes go up to the right. So whenever we have a negative slope, we go down and over to the right. So in this case, it's going to be down 3, 1, 2, 3, and then over 4, 1, 2, 3, 4. And then we just continue that 1, 2, 3, 1, 2, 3, 4. And then again, we're going to go backwards, 1, 2, 3, 1, 2, 3, 4. So we get a full visual of the graph, 1, 2, 3, 1, 2, 3, 4. All right, and let me get a nice line for that. You put your arrows, make sure you put your arrows on the lines and label your lines. So this line would be y equals 3 minus 3/4 x. That's that first line. Let's go ahead and do our second line. All right, we're going to plot our first point, which is our y-intercept, which is 2. If I get my pen to work, that'd be great, which is 2. And then we're going to apply our slope, which is going to be down 1 over 2, down 1 over 2, down 1 over 2, and down 1 over 2. And I'm going to continue this backwards because I like a good visual. Up 1 over 2. Going backwards, up 1 over 2. Up 1 over 2. And we could already see that they intersected. So I'm going to go ahead and draw my line. Make sure your arrows are on your end of your graphs. 3 lines. And as you can see, it intersects right here at 4, 0. 4, 0. So that is our solution. All right. And then obviously you could go ahead and check this and make sure it makes sense. So if we go ahead and check this really quickly, I'm going to do both equations. If we plug in or substitute x and y into both equations, they should make them both true. So we do 3 times 4 plus 4 times 0 equals 12. And this is 12 plus 0 equals 12, which is correct. And then we'll check the second one. We wind up with 2 times 4 plus 4 times 0 equals 8. And as you can see, 2 times 4 is 8. 8 plus 0 is going to be equal to 8. We see that it makes both equations true. All right. And that's how you do it, guys. That's pretty much as hard as I think it gets as far as linear equations, is you just have to put them both into slope-intercept form and then graph them and then see where they intersect. All right, there are a couple of special cases that you may get, guys. Let's take a look at these. I highly doubt they're going to ask you to graph parallel lines, but there are going to be instances and things that you guys should see and notice about parallel lines or lines that, or a system of equations that create parallel lines. And let's go over that really quickly. So, if you guys know the term parallel lines never intersect. So if they never intersect, that means that there's not going to be a point of intersection where there'll be a solution for this system of equations. All right. Now, what we're going to do is we're going to graph these really quickly again. And if we take a look at this, this first equation we have m is equal to negative 2 over 1, and our b is going to be equal to 1. All right, and this equation, our m is going to be equal to negative 2 over 1, and b is going to be equal to negative 3. So I'm going to do the first line in blue, and our y-intercept is 1, and our slope is down 2 over 1. Our arrows on the end, and always make sure that we negative 2x plus 1 label our lines, okay? And then once we go ahead, let's go ahead and do the second one, which is our y-intercept is negative 3, and our slope is going to be down 2 over 1. Down. Parallel lines, the way we can notice that we have parallel lines right away is right here, all right? Parallel lines, all right, we'll have the same slope and different y-intercepts. Y-intercepts, okay? Same slopes and different y-intercepts. So if you guys see same slopes, different y-intercepts right off the bat, you guys know that these are going to be parallel lines, and whenever we have parallel lines, we're going to have, that's going to mean it's no solution, all right? It's going to be no solution. And if you guys don't know, this is the no solution symbol, okay? So there's not even necessarily any work to do here graphically. Majority of the times I highly doubt they're going to ask you to graph parallel lines, but they would probably want you to notice that these are parallel and that would be no solution, okay? Keep that in mind. Now the other instance you might see is something that we call infinite many solutions. And this is basically lines that are exactly the same, all right? And if they're lines that are exactly the same, we're basically plotting one line on top of the other line. And it basically means they're going to be intersecting the whole way down, all right, the whole way. So that means that every point is going to be a solution. So there's going to be an infinite amount of solutions, all right? But sometimes, as you can see, you might not notice it right away. The first one, we saw that there was same slope, same y-intercept right away. But sometimes we have something like this where we actually have to solve for y and compare the slopes and y-intercepts. So if we go ahead and do this, right, we got our first line here. This one's already in slope-intercept form. So our m will equal negative 1/2. Our b will equal 2. This one we have to actually solve for y. So what we're going to do, minus 2x from both sides, solve for y. So 4y is going to equal to 8 minus 2x. Divide by 4, divide by 4. Y is equal to, now remember, we're going to basically divide both of these by that 4 there. and we're going to wind up with 2 minus 1/2 x. All right, so our slope for this one, here is going to be m is equal to negative 1/2, and our b is going to be equal to our y-intercept. Now, if we go ahead and graph this right off the bat, you can see it's the same slope and the same y-intercept. Basically, this is the same exact line. All right, but if we go ahead and graph this, right, we're going to have b, which is 2, our slope, which is going to be down 1 over 2, down 1. Put my arrows. All right, now if we go ahead and did this exact same line, all right, and we plot that line on top of this line, you're going to get the exact same line. We're going to start with 2, we're going to go down 1 over 2, down 1 over 2, down 1 over 2. All right, there's no need to graph these lines, but what I wanted you guys to notice is that if we plot these lines on top of each other, that means they're intersecting the whole time. That means there's infinitely many solutions. All right, and how do we recognize the same line? Well, infinitely many solutions, all right? Let me write this in red. Many solutions, right, are going to have the same slope and same y-intercept. Okay, that's how we realize that we have infinite many solutions. All right, so that's how we can identify that. And now, really quick recap, what we do. How do we understand if there's the number of solutions a system of linear equations have? Well, if they have different slopes, we know they're going to have one solution. If they have the same slope and different y-intercepts, that means the lines are parallel, so there are no solutions. All right, and then if we have the same slope and same y-intercept, the lines are the same, so there are infinite many solutions, okay? They're basically right on top of each other. Now, with that being said, let's see if you guys actually understood what we talked about with the number of solutions. So I got a little bonus question here. Right here, given the equation below, 4x minus 3y equals 6, write an equation that would make a system of equations that would have A, no solution, B, one solution, C, infinite many solutions. So what I want you guys to do is comment below some of your answers. I'll let you know if you're correct, and then if you want, I could do a video on how to determine an equation that would be one solution, no solution, or infinite many solution that would make this a system of equations. All right, guys, hopefully this tutorial on graphing system of equations, solving a system of equations graphically helped you guys out. Listen, I'm Mr. Gooden. Leave some comments below on something else you might want to see. Comment below on your answers to this bonus question, and I'll see you guys next time.